be going through exercise 9.2 from the new Discovering Math textbook, right? This should be in textbook 3B. All right, so let's look at the first question, question 5. So in the diagram, O is the center of the circle, right? Angle AOB is 45, as you can see, right, on the diagram here, over here. And the area of the sector OAPB, right, this shaded area is 30 cm square. So part A, find the area of the sector. So very clear, very quick, right? So the area sector formula is what? Okay, equals to theta over 360 times pi r square. All right, so in this case, it's just for part A, right? It's going to be 45 over 360 times pi, right? Times r square, and is equals to 30 cm square. Oh, I just realized. Part A is to find area of sector OAQB, which is the white part actually. Right, it's actually the white part, but it doesn't matter because we still need to find the radius lah. All right, we still need to find the radius. All right, so and OAPB is still not wrong. This shaded is 30 cm. Right, so our mission now is to find out what is our R lah. So R squared, right, is equals to 30, right? 30 divided by this 45 over 360 pi. All right, so 30 divided by 45 over 360 pi. And this will give me 76.3943, right? So R is equals to square root of that answer. So 8.74038. All right, so how to find the area of the other sector, the white color part, right? So it's still theta over 360, but you need to take 360 minus 45 as a theta over 360 times pi r square, right? But I'm going to use 76.3943 because there is the r square as well, right? I'm missing a 3. Okay, so this is equals to 360 minus 45 over 360 times pi times 76.3943. Okay, so the answer is 209.999. So round off to 10 centimeters square. Okay, so 3 SF, 3 significant figure. All right, so now part B, the black ink on the left. So the perimeter of sector OAQB. So OAQB, OAQB. Okay, and then of course the radius lah. So we got to find the arc lah. So what is the arc? Right, so same thing, 360, right, minus 45 over 360 times 2 pi times r now. So the r is 8.74038. Okay, so the arc is, wait, just let me do a quick calculation. 2 pi times 8.74038. Okay, so the answer is 48.0527. But perimeter, right? So you got to remember to add the two radius lah. So perimeter, right, equals to 48.0527, right, plus 2 times the radius, which is 8.74038. Okay, so this is 8.74038. The answer is 65.5335, round off, 65.5 cm. Okay, 3 SF, 3 significant figure. All right, and this is it for question 5. Okay, let's take a look at question 7 together. So in the diagram, O is the center of the circle of radius 6 cm. The area of the sector OAPB, this whole thing is 35 cm squared. So that's the area lah. So find angle AOB. Oh, so they want this angle over here. Wait, this angle. All right. So since we got the area, then we can form an equation using the area of sector lah. So that means angle, okay, so angle AOB, which is the theta lah. Let me just rewrite it. Angle AOB, which is the theta, over 360 times pi times r square, which is 6 square, right? Yeah, and this is equals to 35. Yeah, all right. So we can just, so angle, do a quick manipulation. So equals to 35 divided by 36 pi. Okay, so angle AOB equals to 35 over 30, 36 pi times 360 lah. Okay, so let's do a quick calculation. So 35 divided by 36 pi, all right, and then times 360. Okay, so that will give us 111.408 4, round off 1 dp, 111.4 degrees. Okay, so 1 dp. So this is for part A. Okay, now part B, on the left, black ink. So the area of the shaded A, okay, so this lah, they want the area of this. All right, so in short, we have to find out the area of triangle. Okay, so we are going to use area of sector minus area of triangle. So area of triangle AOB equals to half AB sine C. So half times A times B times sine 111.4084. Okay, so that will give me 0. Oh yeah, just to remind you guys, it has to be in the degree mode. So 0, because the angles given, I mean the angles found here is all in degrees. So 0.5 times 6 times 6 times sine 111.4084. Okay, so the triangle will be 16.7580. So yeah, the shaded segment ABP. So ABP is equals to 35 minus 16.7580. Okay, so that will give me 18.24195. So round off 18.2 cm squared. Yep, so this is the area of the shaded segment ABP. Okay, so let's move on to part C, the perimeter of the shaded segment. So they want this this blue part. So the arc plus the line, straight line AB here first. Okay, so for this AB, there's only one way to do it, right? We are going to, okay, I mean, there's two ways. It's either cosine rule or sine rule. But for me, I would just prefer to just, do it using sine rule. I mean, cosine rule. So I will just going to write AB square equals to 6 square plus 6 square minus 2 times 6 times 6 cosine 111.4084 degrees. Okay, so AB square equals, wow, quite a lot of things to write. Just let me key in. 111.4084. Okay, so yeah, I will get 98.28095. So my AB is square root of this. It will give me 9.913675. Okay, so that's for AB. All right, now I need to find arc APB lah. Okay, so arc APB is equals to 111.4084 over 360 times 2 pi times 6. Okay, so 111.4084 over 360 times 2 pi times R6. Okay, so this is 11.6666, a lot of 6. Okay, so the perimeter equals to 9.913675 plus 11.6666 lah. Right, so that will give me 9.913675. Okay, so the answer is 21.5803. Round off 21.6 cm 3SF. Okay. Yep. So this is it for question 7. Let's do question 8 together. So in the diagram, the two shaded regions OASD. Wait, I think the printing not very clear. OASD and A, B, Q, C, D, P. Oh, okay. So this is supposed to be shaded as well. Okay, this is supposed to be shaded as well. All right. Okay, and yeah, are bounded by the circle with center O and the radii OB. Okay, OB here, which is 7, 4, and 3. And then here. Okay, so yeah, OC and OB is the same lah, basically. And then OA is 4 and AB is 3 lah. And then angle BOC is 118. All right. Okay, so in part A, find the total perimeter of the shaded region. Okay, now a lot of things to do. Okay, so let's find out the total perimeter of the shaded region. Okay, so first, okay, let's do it in red first, part A. Okay, so let's find arc C, maybe BQC first. All right, BQC. So arc BQC is equals to 118 theta over 360, right, times 2 pi times the radius, right? But the radius here is now 7. It's not 3, it is not 4, okay? It is 7. So I think, okay, anyway, because they say find giving your answers in the form of A plus B pi, right? So you are not supposed to key in the pi. So just key in 118 over 360, all right, times 2 times 7. Then in this case, you will get 413 over 90 pi. Okay, that is for BQC. All right, so now I want to find arc APD. Okay, arc APD equals to theta, which is also 118 over 360 times 2 pi, now times 4. Because this APD, sorry, it is a part of the circle for this small, it's a part of the small circle. And the small circle has a radius of 4. Okay, so 118 over 360 times 2 times 4. So 118 over 45 pi. Okay, so you need to add in the CD and the AB later on. Okay, okay, yes. Then after that, now we need to find our arc. Okay, because we're not done yet, right? We need to find our arc ASD, this part here, ASD. So arc ASD equals to the theta is 360 minus 118, okay, over 360 times 2 pi times 4. Okay, same thing, it belongs to the smaller circle. All right, so 360 minus 118. Okay, I think I should. 360 minus 118 over 360 times 2 times 4. Okay, so 242 over 45 pi. Okay, so last step, okay, anyway, remember, you need to add in this OD and OA lah. Okay, so basically the total perimeter, all right, is equals to 413 over 90 pi plus 118 over 45 pi plus 3 plus 3. This 3 belongs to CD and AB, okay, then plus 242 over 45 pi, okay, and then you need to plus 4 as well. This belongs to ASD, this part ASD, then the 4 and 4 is these two radius over here. Okay, so simplify them now. So 413 over 90 plus 118 over 45 plus 242 over 45. Okay, so I will get not a very nice number. So 12 whole 53 over 90 pi plus, okay, 14. Okay, so this is a total perimeter for the shaded region. Okay, so that's it for part A. So let's move on to part B, right? So area. Okay, let me erase this, the diagram. So area, so area of the shaded region. Okay, this is shaded, it's just not showing. Okay, so basically we want to find the blue shaded, right? So we got to take the area of the big sector minus the area of the small sector lah. Okay, so basically, big sector, right? So 118 over 360 times pi times r square, 7 square, minus 118 over 360 times pi times, the small one is 4 square. Okay, so equal, so you got to, do the workings, but in terms of pi lah. Okay, just give me a while. I'm just calculating. So I will have 649 over 60 pi. Okay, so that's the area for the blue part. Okay, then the area for the small part, the small pink part, right, is just theta over 360. So theta is 360 minus 118. Okay, because of this is this angle here lah. So theta over 360 times pi times r square. Okay, so 360 minus 118 over 360 times 16. So is 484 over 45 pi. Okay, so now you need to add them up lah. So area, total area, right, equals to 649 over 60 pi plus 484 over 45 pi. So equals 21 whole 103 over 180 pi. Okay, cm square. Yeah, so this is it for question 8. Okay, let's do question 9 together. So read the question. In the diagram, OAB is a sector of a circle with center O, all right? And then AC is equals to 7, as you can see on the diagram. And angle ACO is 90 degrees. So this is a right angle triangle lah. Means we can do Tuakaso, right? Or Pythagoras, all right? And then angle AOC is 51 degrees. So for part A, okay, going to do in red. Part A, right? Find the radius of the circle. So as you can see, the radius is either OA or OB lah, right? So I'm going to use OA. Why? Because this is directly related to the right angle triangle, right? As you can see, right, is we can use Tuakaso lah, right? So this is the opposite, this is the hypotenuse. So I'm going to use sine. So sine 51 degrees equals to opposite 7 over OA. So OA is equals to 7 divided by sine 51 degrees. And this will give me, hold on a minute. It's 9.007316. Round off 9.00. Okay lah, you can just write 9 cm lah. Okay, so 3 SF. Okay, so the radius is 9 cm. Okay, very straightforward. A part 1. A part 2, going to do it in blue. Okay, so the height, the length of OC. So they want this part over here. Okay, right. So we can actually use, you want to use Tuakaso also can. You want to use Pythagoras also can. So this will be adjacent lah. So I can say, tangent, right? 51 degrees equals to opposite over adjacent. So OC. Yeah, so OC is equals to 7 divided by tangent 51 degrees. And this will be 5.668 Okay, so 5.67 cm, 3SF, 3 significant figure. Okay, 66848668. Yeah, I scared I write wrong number. Okay, can. So yeah, this is it for part 2. All right, so now in green part B. So hence find the area of the shaded region. Okay, so this is the shade. Okay, so basically I am going to use the area of this entire sector minus the area of this triangle. So area of sector is what? So area of sector equals to theta over 360 times pi times my r square. So 9.007316 square. Okay, so I will have, let's see, 9.007316 square. Okay, so this will be 36.1085 4. All right, so that's the area of the sector. What about the area of triangle? So area of triangle AOC lah. So half times base times height is good enough. So half times base, the base is OC, right? 5.66848 times my height. Okay, so 0.5 times 5.66848 times 7. So 19.83968. All right, so the shaded area of shaded region is equals to this minus this, no? So 36.1084 minus 19.83968. So equals, let me just key in this long numbers. 968. I also scared I keying wrong numbers. So 16.268 round off, 16.3 cm. Is it cm? Yes, cm square. All right, 3SF, 3 significant figure because area lah, right? So yeah, 16.3 centimeter square. All right, and this is it for question 9. Okay, this is the last question of exercise 9.2 that I'm going to go through. So this is question 10. Right, so the diagram shows a sector OAB, right? OAB here, this is the sector, the white color part of a circle with center O, and then C is a point on OB produced such that angle OAC, so OAC is 90 degrees. All right, so that means we can say that CA is the tangent to the circle at point A lah, actually, right? But anyway, not the point. So not like the whole thing lah, not the thing here lah. So AC is 17.5 and BC is 7. So they asked us to show that the radius of the circle is exactly 18.375. So basically, right, I can label, okay, I'll label the diagram. So OA is the radius, OB is the radius, right? So actually, if you think about it, we can actually form an equation using Pythagoras theorem. So part A, so I can say that what? R plus 7 square, right, is equals to R square plus 17.5 square. Make sense? R plus 7 square over here, right? This is the hypotenuse, is equals to R square plus 17.5 square. Okay, so let's expand this and do some algebra lah. So R square plus 14R plus 49 equals to R square plus, what is 17.5 square? Let's see. 306.25. Okay, so both sides got R square, right? So you will minus away lah. Okay, so we have 14R equals to 306.25 minus 49. All right, so R is equals to, okay, let me just do the minus first. All right, and then I divide by 14. All right, so I will get 18.375. Yeah, so shown. Okay, so this is for part A. Okay, now let's find part B. So angle AOC, hence, right, AOC. So they want this angle over here. All right, so very simple. Yeah, we can actually use Pythagoras theorem. Tuakaso, because this whole triangle OAC, right, is a right angle triangle. All right, so because we want to find this, so this will be the opposite. This will be the adjacent. So tangent lah. So tangent angle AOC equals to opposite 17.5 over adjacent, which is 18.375. All right, so angle AOC equals to tangent inverse this fraction. So tangent inverse 17.5 over 18.375. All right, so this will give me for the 3.60281. So round off for the 3.6 degrees, 1 decimal place. Okay, so this is it for part C. So let's move on. Part B, sorry, part C. I'm very eager to end. Okay, part C. So find the area of the shaded region. So this thing over here lah. So basically, we have to find the area of the triangle minus the area of the sector. So area sector first. So area sector equals, right, theta, which is 43.60281 over 360, theta over 360 times pi times your R square, which is 18.375 square. Okay, so this will give me 128.474. Okay, so that's the area sector. Now we need to find out the whole triangle. So okay, maybe I need to write this. So area of triangle OAC, all right, equals to half times base times my height, which is the R lah. So 18.375. So 17.5 times 18.375. So it will give me 160.78125. Okay, so just minus to find the area of the shaded lah. So area of shaded region equals 128.474 minus the other way around. It should be 16. I mean, you have to use the area of triangle lah, right? It's obviously bigger. So 160.78125 minus 128.474. Okay, so this is equals to 32.307, round off, 32.3 centimeters squared. 3 significant figure. Okay, all right, yes. So this is it for the last question of exercise 9.2, and this is question 10.